All right, so what we're doing, we're picking up on where we left off the last time. We're looking at vectors. We're kind of looking at vector basics, ideas that we need in order to do vectors well. All right. So there are a number of little things that we need to have as we go forward. All right, so let us start off by looking at how algebra is used in vectors. So be advised that sometimes you could be given, let us say you could be given a vector in a form like that. And where we know that we get a number at the top, a number at the bottom, and we know what those are, X and Y values. So you can get the vector like that. However, you can be given the vector in an algebraic form where they might use a letter, sometimes with a little dash at the bottom, or sometimes with a little dash at the top, or they might just leave it as is. So you could get a variable to represent your vector, and you're just gonna take it as that. So you're gonna think algebra. So we wanna take the time out to at least just look at how do we work when we get the algebra. For example, all right, so let us say we have, let's put a little subheading. All right, so we want to look at vectors when we have an algebra idea. For example, so you could write with me here, draw these things with me with your free hand. So let us say we have this, and this might be anything. I'm gonna put O, I'm gonna put A, and I'm gonna put B. All right, at this moment, we can be given information whether they put the labels on the diagram or aside. So having this, looking at, they could say to you that, they could say that OA is X. And they could do that. And they don't have to. I'm just saying, just don't think too much. They could do that as well. So that is OA, right? And you could be told that OB, and you have to look at the arrow system that you get is like that. So now you're seeing algebra coming in, right? So what I would normally do is I would look at the diagram and I look at the arrow that I have. This is very important. So you're noticing that the arrow, right? The arrow that we have is pointing from O to A. So I'm going to put an arrow on this to suggest that, hey, this is the direction for me to call this X. Now, if the direction switch, it is no longer X. It's going to be the negative X. Remember, we spoke about that. If you change the direction, you change the sign for the component. So be advised that this is X going that way, and this is Y coming this way from O to B based on what the question specifically named like that. So I don't want us to overthink the idea, right? Now, let's look at this. Here is the idea. Now, the question, there could be a simple question that says, watch this. It could say, right? Everybody, right? I hope you write everything that I have on the screen. Right? AB. Right? Write AB in terms of X and Y. So they could do that. All right, they could do that. So don't stress yourself. You're seeing that we have these, here they are. All right. Now, normally whenever you're given a vector, all right, it's always a way to try to connect 2 points. For example, you want to move from A to B. You notice that there's an empty gap there. You want to travel that distance. Every time you're doing a vector, the vector that they ask you to find, you're going to have to find a road that could take you from one point to the next. So in reality, you really want to do this. You want to move from A to B in that direction. All right. The direction is important. So I'm going to put on it. You want to travel this, A going to B. I'm suggesting that remember that you're at A and your intention is that you want to end up at B. Walk along the road that you have. And I'm going to highlight the road for you in green. You want to walk from A to O and then walk from O and you arrive at B. Remember, you're starting at A, you're ending at B. Look, there should be some connection in terms of a road that you could walk along. So in this case, you can write up that AB is equal to moving from A to O plus you're moving from O and you end up at B. Remember we said that your beginning point and your end point are on the outside if you're walking like that. All right. So what you want to do now is to look on the arrow, making sure that you are correct in terms of the right label. So remember now we got OA, but we need AO. So it's going in the opposite direction. The opposite direction suggests that there is a negative sign that's going to affect the original thing. So it's no longer X because I'm going in the other direction. So it's a negative X. And then OB is the same because I got OB here. So I'm not changing in the direction or anything. So I put my positive Y. And that's the answer. So when the algebra comes in, it's not a big deal. Look at whatever they have and you're going to still do your walk. A vector is just a walk through a common point to go to somewhere. Any question?
Sir, how you get negative?
You get the negative whenever a direction is changed. All right. I don't want to say negative. I want you to understand properly. This was a positive, but it's going that way. Can you see the arrow?
Yes, sir.
So it's going from O to A, which is this. This is what you got, O to A. You see that? Arrow, look at the arrow right there.
Yes, sir.
Now, when you decide to find what you want to find, look at this. Is this O to A or that's the opposite direction? Jody, I'm listening for a response.
Opposite.
Huh?
It's the opposite.
Exactly. So when you realize it's the opposite to the information you have, you change the sign. So it was a positive X. Therefore, it must be a negative X because I'm going in the opposite direction. Get it good now?
Yes, sir.
This is what vector is about, and it doesn't get any harder. You just have to do that. You just have to look to see what you have and where you're going now. If you're going in the opposite direction, change the sign. All right? As long as you're in the opposite direction, change the sign. And when I said change the sign, just be simple. Be simple. If it is negative, it's now going to be positive. If it is positive, it's going to be negative because I'm not going in that direction. A change of direction is a change of sign. Be advised. All right. So basically, I'm just saying, I mean, when the algebra comes in, that's it. All you're going to do is to work algebra. There are times when you might get a number of things to be added. It is still algebra you're doing. For example, let us say that you have this. Okay? So this is point P, Q, R, S. And then on this, I have A, I have B, and I have 2A. And the question says, right? This question says, we want to find PS. So you wanna move from P to S. That's the vector. P to S. This is P, this is S. All right. So we want to go there. Let me just drop it here. This is what we want to do. P S. That's us. We want to go that way, right? Now let me fix the arrow brighter. So we're going that way. Question. You focus on the question. Now, if you want to go that way, you're like, that means you would note for yourself that you're at P. You are at P, right? Because the question said P to S. So then you look at what you have, and based on your situation, tell me if this is correct. I'm going to move from P to Q. Then I'm going to move from Q to R. Then I'm going to move from R to S. I am suggesting that you observe your walk. A vector is just to walk, and you're adding the distances as you walk, right? So now, when you look at this, what I just said was just that we're going to be moving from P to Q, Q to R, R to S. And you would have seen that you have arrived. Indirectly, you move like this. This was your journey. That's the vector. But you accomplish the vector by walking along the blue road. All right. So that is all vector is about. Where am I going? What's the channel that can take me there? So what we're gonna do now is to simply, what is from P to Q, right? So let us say I'm putting on some arrows on this. So watch me now. Putting on some arrows on this, arrows on this. All right. So I'm putting on the arrows on these. All right, because I want you to see something. So the arrows will determine what you do. So on the diagram, look, if the diagram is not given with the arrows, then the question would have told you something, right? So you have to be looking out. So in this, the diagram would have the directions for the components. So this one is going that way. This one is going, you could see. So now based on what I want to do, I might have to change a thing to negative or whatever, depending on the direction. For example, I want to move from P to Q, but the arrow that we have here, the arrow is, this is not P to Q, it's Q to P. The arrow tells that. Look at the arrow, it's moving from Q to P. But if I don't want to go that direction, and I'm on the same road, all I have to do is to change the sign. It's positive. That means it's going to be negative A. I just want to know if everybody see that first one right here. This.
Yes, sir.
I am going PQ, but the diagram would have the arrow going QP, the arrow. Remember, vector is about your direction. It is so imperative that you understand your direction. So my direction is opposite to the arrow. Change the component of the label for it. Now, are we okay moving from Q to R based on the arrow? Yes. So it's going to be a plus B. Now I need to move from R to S, but look at this. This is SR. The arrow is pointing from S to R. So I have to go the opposite direction. So it's a negative 2A. Because the arrow is going contrary to what I want. All right. So what we want to do now is to, so when you're doing the things with vector, you have to simplify because you're doing algebra like terms. So in other words, what am I looking at? I'm looking at negative A and negative 2A together. That's going to give me a negative 3. Regular math you're doing, this is negative 3A. And there's a plus B. Guys, your algebraic skills is required, and it is simple algebra, like terms, right? Negative 1A, negative 2A, That's negative 3a, right? So the vector PS is simply negative 3a plus b. Or you could have written the positive first and the minus after. It doesn't matter. You understand? So if you write b minus 3a, it's the same thing. All right, we want to embrace our algebraic skills. All right, so we have some things on the board there. Take it off. Take it off. And that is just the algebra. You just need to be introduced to algebra in terms of understanding that they could give variables, all right, for your vector. And when you combine variables, you're still going to be adding or subtracting like terms. Just the same. There will be no multiplication of terms. All right, it's adding and subtracting. All right.
Excuse me, sir.
Go ahead, I'm listening.
Will the arrows be there at all times?
No, no. The arrows may not be there, all right, but they will give enough information. Meaning, if the arrows are not on the diagram, they are going to give you the vector with the arrow on top of it. For example, if the arrows, notice I'm saying if now, if I never put any arrow on the diagram, I would have had to tell you that QP, I had to, is A. I would have to tell you this. I would have to tell you that also QR is B. If you understand what I'm saying, Miss Scott, if
Yes, sir.
if the arrow is not on the diagram, you would have to get the information straight up, because nobody would be able to solve the problem without that. I can't do it, you can't do it. So it's either it's on the diagram or it's labeled up properly, or you get both. Sometimes you get both, but definitely the arrow would have to be there. You know why? Vector is about direction. All right, good question. Sounds like you're saying that you might do a good job, eh? All right, go ahead, I'm listening. Miss Young. Oh, Mr. Young or Garrett. TJ, your window this. Check them out. Somebody wanted to say something?
Yes, sir. Good evening.
Good evening.
Can they turn, Karen? Can they turn the arrow the other way, sir?
They can turn the arrow anyhow, but that's fine. Okay. What you have to do is to look at the letters. Look at the letters on the arrow, and then you would have to decide based on the. All right. So generally speaking, if you are not going in the direction of the arrow, just change. If you know that you're going the other direction to the arrow, just change the signs of the label or the component for the vector. That's all. All right. It's either you're going in the direction and keep whatever you have, or you're going the other direction and change it. That's all.
Sir.
Go ahead.
Sir, could you go over? Can I go over to the left, sir? I saw some things that you write on the left, sir.
No,
yes,
it's
sir.
not. It's not. You don't need to write. Somebody asked a question and I was explaining to them.
Let me see, sir. I didn't see when you write. No, let me see what you write.
It's on the screen, man. I was responding to a student. It's not a part of what we did. I was responding to a question by explaining this. So it's not a part of the working. All right. All right, good. All right. Let's move the screen up. Let's move the screen up. All right. All right, watch this now. Let's get into some, I want to show you some things that you must have up your sleeve in order to do well. And then I want to show you, there are a number of things I have to show you right now. All right, one is that you have been doing this, so I want you to focus a little bit more on what we call the triangular law. I think I'm going to use an adjectival form. So I'll say triangular law of vectors. All right, what is this? This is simply saying that whenever you're asked to find a vector, there is always a solution. I don't want to say all, 9.999 out of 10 times, there is a triangular walk that could take you there. That's all. There is a triangular walk that could take you there. You have been doing it, so I'm just going to reinforce the idea. Everybody just do this with me, saying like what I'm doing now, do it. Just draw up your X and your Y, freehand, just like that, freehand. All right, so let us say that we have a line here. And this line is A. This point here is A, and this point here is B. All right, so I'm gonna kind of put some fake labels to the idea, right? So this could be 2. This could be 2, 6, and this could be about 7, 2 or 7, 3. All right, that's it. All right, so basically the point A is 2, 2, 6, the point B is 3, 7. And if I want to display AB, I remember it's not always about AB. I'm just choosing the letter. It's just easy to write. So if we want to display AB, we're talking about you. They want you to find this vector AB. We are saying that if you're on this system, there is always the origin there. It simply means then you could walk from A to O and then move from O to B. Look at the arrow. Look at the arrow. All right. So that's what we're saying. So you could see the moment you decide to walk, you see the triangle coming. That's what we're talking. And you have been doing this. It's just that I never told you that it's a triangular walk, right? Yeah, man, do your thing. All right, it's all right, Ms. Scott. So what I'm suggesting is, there is always that triangle that link, the triangle that is linking. All right. So now, if you look at this, remember the last class, we're saying that if you have the coordinate of a point, you technically have the position vector. So I could write it so you could see. We have O, A, and that is 2 with 6. That's the original thing. It was not given to you, but the fact that you get the coordinate for the point A and you are on the grid, then you have the vector from O to A, which is 2, 6. And you also have O to B, which is 7, 3. We spoke about that last class. So we're suggesting now, remember now I show you 2 ways in which you could have done this. One of the ways you could have said is you want to move from A to O, plus you want to pick up now from O and head to B, and you have arrived, because this is you starting at A and this is you ending at B, and there's a common taxi between, right? So we spoke about that as well. So then you want to observe carefully now. This is AO, so it's going to be the opposite direction. So it's going to be a -2 and a -6 that you will be using, because you're not going in the direction of the position vector. OA is the coordinate. OB is the coordinate. So the fact that you realize you have to go opposite to it, fine, change your sign. We want to add that to OB. OB will not change. So it's going to be 7, 3. Why it is that OB isn't changing? Because I am moving in the direction of OB. Based on how I want to move from A to B, I'll travel from O to B. Finally, now, you're back at your class in matrices. 2 plus 7, 5. -6 plus 3, -3. There you go. That is the vector AB. Go ahead, I'm listening to you speak.
Sir, how is OA to 6, but the arrow is moving from A to O?
No, the arrow is not for OA, you know, the arrow was for what we have to do to arrive at AB. You get what I mean?
Oh, yes, sir.
That's us talking to ourselves. All right, so in this question, I did not give you OA, but the previous class would have told you if you have a point on your graph and you're on your coordinate plane, X and Y axis, the moment those are on it, then you automatically have position vector. So nobody will necessarily would have to tell you that you have OA, which would be the coordinates of the point A, but in a vector form. Look, the 2, 6 is the same 2, 6. So you have to embrace that knowledge that when you have the point, you automatically have O to the point. Whether or not they give it to you, it is like the original thing, whether or not they want to tell you. So you have to start owning that idea. So that is what, this was our walk. We knew we had to walk to here and walk, go that way. We knew that we had to do that. All right. I think you understand now based on what you're seeing.
Yes, sir.
All right, good. All right, so again, I'm just gonna show you one more in terms of the same question. Remember we said that we can do AB like this or any vector. The last one, write the position vector first. So B, the position vector is OB, and you wanna take away the position vector of the first one. And when I say the first one, I'm talking the first letter. Look, AB, you write the position vector for the B, then the position vector for the A. Technically, you know, it's the same thing like this under this, guys. All right, let's talk. What is a negative in front of OA mean? Anybody? A negative in front of OA means that it turn around to AO. True or false? A negative in front of,
that's not in the direction that you want it.
it means that it exactly. So I'm just saying to you that it is the same math and the style, because if the negative in front of OA, it means that we are traveling AO, true or false. This, it means that we are traveling this. So I'm just saying it's up to you, whichever way you want to do it, you'll get the exact answer. Look, 7-3 subtract 2, 6. Look for yourself. Exact answer. 5, -3. So it's up to you to embrace whichever one you want. I'm not here to tell you what to do. I do any one of them when it depends. I see when I just start writing because I know it's the same thing. All right, so that's what we call the triangle walk. When you're supposed to move from one point to the next, and then you find one common ground, go there, and leave from there to your destination. That's a triangular walk. And I always say to you, you leave so those of us who work, you're talking about from home to that town area to get your taxi, and then from that taxi stand to the work. And you would have reversed the journey coming back home. It's the same vector walk. It's a triangle. All right. All right, guys. Still on the idea of the triangle walk. So you're going to be using a lot of the triangle as you go through all the questions. You're just going to see. So the moment I start the questions, you're just going to see triangle, triangle, triangle from now until morning. All right. So we want to understand the triangle walk. Pay attention to details and work your math. All right. All right. Just one other little thing. It's just a reminder. Go ahead.
Did you say 6 from 3 and you get a -3, right?
Yeah, 3 - 6. Yeah.
Yes, thank you, sir.
3 - 6. Because you're just flowing. You're not, 3
Yes, sir.
- 6. And you
Yes,
get back the
sir.
-3 that we knew. So you kind of see that the two methods, they're actually identical twin. A lot
Yes.
of things might appear different, but it's not. Appearance is not necessarily the reality, So it only appears different, but it's the same concept.
Yes, sir. Thanks.
All right. There are some little stuff I still want to. All right. So a quick reminder of this. This is a reminder. So I want you to take this down, you know. Let us say, I'm not working out something here. I'm not sure if you guys wrote down this, but we did, remember when we were doing the length of the line? I'm just gonna write this for you. Let us say you have a vector from P to Q, and you want to find the size of that. We spoke about that, you'll see this. And in a vector world, it means the length of that vector. You measure from P to Q. And so I'm just giving you as a reminder again, the formula is to have the x coordinate square, the y1 square. You take the square root, that's all. Just a reminder. And that's what we have been doing. Square the components, add them up, and take the square root. Same thing. So I'm just writing this so that you can see that that's kind of a little formula, you know, you could go by. And this is on the basis that this is x and this is y. That's what we're talking about. That top number square, that bottom number square, add them up, take the square root, and we get the magnitude of the vector. And you want to make sure that you can find it, because vector is about magnitude and direction. All right. Still taking some notes, and then I want to show you, you know, I mean, 1 and 2 questions, but we have a lot of little notes. All right, there's another walk here that is still triangular, but when the triangle double up, we end up getting what we call this. Parallelogram of vectors. All right. Parallelogram of vector. So if we understand what a parallelogram is, then it's going to be the same idea here, right? 1 second. One second, guys. All right, I'm here. All right, so let me draw it quickly. When we talk about a parallelogram, it is that same thing that says opposite sides are parallel. So I'm putting the arrows to head in the same direction. Opposite sides. So with a parallelogram, property is opposite sides are equal and they are parallel. So opposite sides are equal and parallel, and this is what a parallelogram is. Opposite sides are equal and parallel. All right, so what that means is, let us say this is, say, A, this is B, this is C, and this is D. I want everybody to draw a little thing like this with me as well. Because opposite sides are equal, then we're talking about from A to D, watch my arrow, is the same as from B to C. And when I said it's the same component, same everything, all right? Because it's a parallelogram. They are the same length and they're heading in the same direction. So we're talking about from A to B. It is also going to be the same as, you notice I said A, so I'm coming from up here, coming down. I will have to say D to C. Don't twist it around. So if I'm coming from A to B, I have to say it's equal to D to C, the same direction. And if I say B to A, it's equal to C to D, going in the same direction. So look out when you're writing the things, you know, go in the same direction. So this is what the parallelogram law says. That's all. So the parallelogram law is suggesting that understand that the opposite sides are the same. And what that means, if I have a little a here, it means that this is a little a as well, because it's a parallelogram. If I have a negative b here, it means that this is a negative b as well, because it's a parallelogram. Opposite sides are equal and they are parallel. Now, in the event that I want to put some more decoration on our diagram, for example, if I should have a line, one of the diagonals here from B to D, right? See, I'm looking at the diagonal from B to D. So I'm going to put an arrow on it. So I'm moving from B to D. You're going to realize that look at this. So with the parallelogram of vector, the diagonal BD, you're going to realize that you can get it two ways. Watch. You could move from B to C plus move from C to D. Tell me if you agree with that triangle. You walk from B to C and then you move from C to D. Now, if you never wanted to do that, you could have moved from B up to A and then moved from A and landed at D. I'm suggesting that if you try to work these out, even though they look different, I guarantee you'll get the exact answer. Let's try. All right, so with the parallelogram of vector, you might have more options depending. So let us look on B to C. So look at B to C, it is little a. Positive a because I'm going in that direction, so I write my a. And then C to D, I'm going in the same direction.
Let me forget a new laptop in a car.
Talking to me? All right, take a look. So we're talking about A plus a negative B. So at the end of the day, it is just A minus B. Everybody want to agree with that? From B to D will be A minus B. I want one confirmation for that, just one.
Yes, sir.
All right. Now, I was saying that we could have found this another way. Let's look. You could have moved from B to A. So we're going in the correct direction. So it's a negative B. And then you're going to move from A to D, which is a positive A. Look, same thing. Negative B, positive A. So if you want to spin this around and write A and put the negative at the back, doesn't matter to anybody. It's okay. I'm just saying, we took two different routes and we ended up with the exact thing. It is because in the parallelogram law, the opposite sides are equal. So when you claim that you're going in the opposite direction, yeah, it's another route, but it's the same distance you're actually covering. So that is the parallelogram thing. Now, what it is you need to know about parallelogram, I said it here. I said it. You need to know that opposite sides are equal. And then they are parallel, which means one is a scale factor of the other. One is a factor of the other. Even if the factor is number one, the moment you can multiply one vector by anything and the next vector shows up, it means they are parallel. And I did say anything, whether it's 1 or a half or a quarter or 10, it doesn't matter. Because there is nothing I can do with A and it turns into B. So you know that they are not parallel. When you realize a B and another B should share, they're sharing something. So the moment you are able to find something, it means that they are parallel. All right. So you have to just be on your A game when you're going to exams. Words are important. The moment I see a parallelogram, I would understand that if they ask me to prove it, I need to write down these. If they ask me to prove that something is a parallelogram, when I identify the four sides, that means I have a sketch I can just randomly, well, not necessarily random, but I could just pick the opposite sides and said, well, if this is a parallelogram, AD must be equal to BD, AB also must be equal to BC. I can pick those. And I can guarantee you it will work out fine if it is a parallelogram. All right, these are notes. All right, so I'm giving notes, and hopefully by the end of the class, I will be able to. I have questions already to throw a few questions on the board and then watch us amalgamate the whole thing from the last class. How do we use that to solve the problems? Mark you, I have questions that are a little bit more challenging than what you'll be getting. There is no 15-mark vector question, no. But if I pick up a question like from certain years in the past, because the content is still good, it might be longer than what you'll do, but it is a good workout for you so that anything they ask, you will be good with. So if you see a question like that, you won't get any 15-mark vector question, all right? But the ideas, you can get them in pieces. So nothing is wrong if you go through. All right. All right, let me jump into more ideas, right? All right, so I'm giving ideas. So one of the last piece of idea you want to be able to navigate is that you want to be able to learn how to share up line. All right, I realize sharing up of line is very tricky for people. So I want everybody to flow with me and remember to watch over your thing, watch over the video, people. All right, there's a reason why I do it. All right, so let us say you have PQ, and you need to follow instruction that I'm going to give now. Watch this. There is a line PQ, but X is on that line. Watch, X is a point on that line. So X is on that line such that this happened. Watch. PX is 1/3, right, of PQ. That's what they say now. So they give you stuff like this. They'll tell you X is on that line such that from P to X is 1/3 of P to Q. They might give you what Q is, PQ is. They might tell you that from P to Q is little a. Or you could get components like a 6/9 or whatever. Same principle. Now, this is valid information. You're just being told that P to X is 1/3 of the entire journey. No problem. I don't have a problem with that. So now, if the question wants me to do a few things after, maybe I need to find PX in terms of I need to find it. Because remember, from P to Q is little a. So PX would have been something about A. We want to find that tonight. Also, we want to know what is XQ tonight. We need to find those. So we're going to talk about it. Now, I want you to think numbers now. So you're back on numbers where if from P to X is 1/3 of the entire thing, then you could say that if this is 1/3, that means over this side is 2/3. Because if that side is 1/3, the remaining side must be 2/3. Tell me if you agree with that.
Agree, sir.
Yeah. Yeah, man. All right.
Sir, come again, please. Come again.
No, I'm just saying to you, you have to be simple. If from the entire line is from P to Q, and if P to X is 1/3, I'm saying the remaining distance must be 2/3. Straight up. What do you think?
Okay, sir.
If from P to Q is 1/3, P to X is 1/3, then if you pick up from X to Q, it must be the remaining to make the whole. So I'm just saying it's regular. All right? Yeah. So then you can look now, if they label everything and says from, so you got this, you got P, Q is A. That means PX is 1/3 of A, true or false? Simply, no. From P to X, wouldn't that be 1/3 of the A for you? Because everything is A. And P to X is 1/3 of the entire journey. So it's 1/3 of A. And then X to Q is 2/3 of A. Check it out. Just tell me if you agree or not.
Yes, sir.
You know why I'm giving you these to do? Because 9 out of 10 times, they are going to give the relationship. And I don't think it's difficult. You just need to probably see a few and know that, oh, yeah. So when you get those relationships and labels are given for your lines, your vector, learn to split it up, man. Or understand how it's going to split up. It's not a biggie. Relax and look at what they say. All right, so that's one situation. I want everybody to take it off. We are saying take it off. All right. Let's look at another. If I have Mn, if this is M, this is N, and there is some point here, I'm calling this X, and you're told that X is the midpoint of Mn. That's a very big statement. They're telling you that X is the midpoint of Mn. Fine. Now, let us say that the arrow is pointing that way. And this is 2b. So from M to N is 2b. So Mn is equal to 2b. You get that? See there? Then if I can ask you what is Mx. Also, I can ask you what is X to N. Going in that same direction. I remember, and if I change the direction, you have to be careful. So at the same time, I'm going to say, what if I want X, M? Or I might want N, X. No problem. All right. All right, let's take a look. What does midpoint suggest to anybody? Midpoint is a clue.
Half.
So like,
It's in the middle. It's off.
in the
Half
middle.
of it.
Yes. So you think about middle, you're thinking of half. So we're talking about this is half of the journey, and this must be the other half. So it is going to be sharing equally. So that means from M to X, it's going to be what? Anybody want to just suggest? This is 2B for the entire journey. 1B, so you just call it B, right? You just say B. So Mx is B, and that means from X to N is also B. Because you're sharing it. And since it is 2, this person will get 1 out of it, and you will get 1 out of it, because we're sharing that equally. All right? Now, look at coming the opposite direction for XM. XM is going that way. The arrow was already going the opposite direction, so we have to change the sign, and this becomes minus B. See that? Because you're going against the truth that you got. So it's now a minus. Look at N to X. N to X is going against the arrow again, because you're starting at N and you're going towards X. So the component would have to change its sign to facilitate the direction of your flow. That's what we're saying. We want you to be conscious of what they ask. Don't just write down things. Look at what they ask, because the arrow will tell whether or not it's going to be a positive or a negative. How does that sound? Clear?
Yes, sir.
All right. I'm just kind of teaching these ideas. You know why? Because if I start a question now, they will give some instruction like this. All right. Trust me. So you want to at least get a feel. All right. Let me give you one more like this, and then there are two more. There's one other unique type I need to give, but I want to give you one more like this first. Let us say we have a thing like this. Maybe this is CD, right? And then there's O on this line, O. So O is on that line, so we have the arrow coming this way. And O is on that line such that C to O is actually a quarter of CD. See that? So they love to give those. So this is saying from C to O is just a quarter of the entire journey. All right, no problem. If I know that, and you're telling me that this is P, then I can divide up the P, right? So if you want to know in terms of P, what is CO, it's just gonna be a quarter of that P. Yeah, because P is for CD and CO is a quarter of CD. So I'm going a quarter of P. And if you want from O all the way to D, it's going to be the rest of the journey. So it's going to be 3/4 of that same letter P. If you should add back the quarter and the 3/4, you're going to get back that 1P. So you know that the idea is correct, right? So we are suggesting that you look at the instruction. These are important. Relax, see what they're saying, put it in the right perspective, and then wait to see what they want to find. I am just giving you these because I'm saying they could want you to travel along that road, What do? You want to be able to write it, to know what it is when you see it so that you can use it. All right, I'm gonna leave it on the screen, but I'm gonna put it up like right here. And in the meantime, I'm gonna put the last relationship that they would give. So they would give you a midpoint, they can give you a fraction, and they could give it in a ratio. Like they could say this to you. Let's consider this line. RS. You notice we are in vectors, but I have to stop to let you understand what's going on. Now, it could be said that RM2 MS, all right, is equal to 1 to 3. They could do that to you as well. They could tell you that from R to M and M to S is 1 to 3. In other words, they're telling me that this is 1 to 3. See that? That's what they're telling you. Now, when you see this, you need to make sure that you understand that this line is divided into 4 pieces. Because if you give me ratio, I could know the total parts. The total parts is 4. And then RM get 1 out of that. And then MS get 3. So it's the same quarter and 3/4, but they put it in a different way. All right? Because if you get 3 out of 4, that's 3/4. And if you get 1 out of 4, that's 1/4. So then if this is, say, 8x, right? 8x, and we're heading that direction. Now, what if I want RM in that direction? And then I want SM in the other direction. All right, RM. What is RM? RM is actually a quarter of the entire journey. Would you agree that RM is a quarter of the entire journey? Yes or no? RM.
Yes, sir.
Yeah, because it's 1 out of 4. So then you can relax and work it out. It's 1/4 of RS. No rush. You want to understand what you have. It is, which means it's 1/4 of 8 x, yeah? And then you say, oh, you could divide out that and you're gonna get 2x. Tell me if you're all right. Let me put it over here. 2. And you could already take it long time, you know. I'm just showing you step by step. Okay, you could say quarter of 8 is 2. You understand? So it is 2x. So Rm, 2x. Now, Sm is going in the opposite direction of the arrow. So already we know it's going to be a negative. But it is actually 3/4 of the journey. Because it's 3/4. But it's actually going to be a negative 3/4 because it's going the other direction, right? So we could start putting our negative right now if you want, because you would understand that the arrow will change. So you could say it's negative 3/4 because we're going in the other direction, and it's negative 3/4 of Rm, Rs, which means it's negative 3/4 times 8x. And you will see your negative 6x because it's coming in the other direction. So it has to be a negative. And these are the only things you need to look out for. How am I looking at my direction? Am I viewing the directions right? So this is your algebra coming here. But at the same time, you're doing vectors. But the algebra is not a big algebra. But every now and then, they will label the vector using algebra. Be comfortable to find fractions of a term and so on. No biggie. All right. Anybody with a question? Joe, what are the give me. All right, guys.
Sir, could you bring down the screen just a little bit?
All right. Tell me what you want me to do. I could minimize it like this and do that. Is that fine now?
Yeah, that's good.
Thank you, sir.
Thank you, sir.
Sir,
I'm listening.
the one where you have C, O, sir, and you have quarter D.
Yes. I have a quarter. When you say I have a quarter what? Quarter what?
You have D.
Dean.
D.
All right, you're talking the third one, this one here.
Yes, sir.
It's not a Dean, it's a short leg P, man.
It's P.
Yeah, it's the same P, this.
Because I was wondering.
Thank you, sir.
All right, good. All right, guys. What I'm going to do now is I'm going to start walking you through how these things now, everything that you just looked at, how it comes back. Let's go. All right. I didn't send these paper in the group, but I think I have them here, number 1. I'm kind of taking them in order. All right, so I'll put them out in there, open. All right, give me 1 minute. Let me just put this one at the front. So hold on, I need to put these by themselves. 1 second. All right, there it is. This is 60%, 70. I could go this up bigger. All right. All right. All right, we could look at that. All right. Typical question. All right, so, all right, there you go. That's a typical question. All right, so we could look. Remember to watch over the recording. If you're going to watch it over and screenshot or whatever, I don't know. So here it is that they give us. See, they give a triangle, but they don't have to give it a triangle. What you're noticing here is that, look, they give you information. It says the points O, Q, R, and R have coordinates 0, 0, 5, 2, -1. You see, this is their way of telling you that it's a position vector without telling you. Remember, I said the position vector will start at 0, 0. And they call it O here. They even tell you that this is O. So this is O, this is Q, and this is P. But they never wanted to call the word position vector. So they just give you some stuff to say
Sir,
if you remember. Go ahead.
that
Yes?
means R.
Oh, you're saying me to write this. That, okay, let me fix it. All right. So we got the coordinates for the 3 points you're looking at. Nonetheless, whether or not they gave it to you, you would have seen them. It's there. All right. Now, here's the first question. It says write OR as a column vector. OR. O. So when you see this OR, OP, OA, OB, we know we in the position vector thing. O to R. So if you know the coordinate of R, you should know what the vector is. I need somebody to tell me what OR is. OR. What's the vector for OR? Anybody? What's the position vector for OR? Position vector. Let me call some name.
Or would that be a quarter?
Nope. Vectors. It's coordinates. This is the current. So it's not about over coordinates. So -1 at the top, 4. Components. Remember, it's not algebra, this one. You understand what I mean, Karen? So you have to know the difference, because yeah, it's very different too. You're looking at it, you see that it's very different. But I think I understand what you're saying. But if you make the mistake in the exam and do this, you're in problem. All right. So -1 at the top, 4 underneath. So it's in the column form. And worse if they use the word column. You see what they use? They use the word column vector. Anybody remember column matrix? You see the link? Column matrix they did? Column vector, same thing. All right. So you don't want to spoil it. All right. So that is all they want right there. They want to know if you're able to read that. So you read it off. Now let's see. So you get, it's not more than a mark. Sometimes they might give you 2 marks for this. But let's push. Another question says.
Wait, sir. Go back to. You said the OR is, say it again, -1.
Let me write, I'm going to write it down here. So OR is -1, 4. Coming from this. Look, R, remember we tell you that already, that if you know the coordinate of a point and you're on the grid, the position vector is just to turn it in a column form. So the -1 and the 4, see it there? It's already there. So don't waste those marks. Those are giveaway right there. Karen, good to go?
Yes, sir.
All right, look at the next question now. So I'm going to go back up there, but I want you to look at it. They want you to determine, everybody knows what this means? What they want?
Length.
The length of.
Sir.
All right, so they want the length of the vector QR. So keep that in mind, QR. Look for yourself. You're seeing Q, you're seeing R. You have every bit of information you have. If you're going to find the length of it, you're going to need to have the vector. So I'm going to allow you to try to find the vector QR for yourself. Remember now, let me put the coordinates because they gave it to you. They told you up there that this is 5, 2. And they told you that this is -1, 4. This is 0, 0, they call it O. See there? You're on your own and I want to see if you could find QR magnitude. But to find the size of QR, first you need to find regular. find the vector QR, and after you have found it, then you can now find the length of it. So that's the process. Find it first, and then you go ahead. And remember, I know you're on a grid, you learn how to count, you're on your own. I want to see what you're going to do. Because this is Q, and this is R. That means the arrow turn like this. Q to R. I can go there a number of ways. Let me see what you do. You done? I know I did. All right, let's look at it now. All right. All right. I'm gonna rush it. I'm gonna rush into it. I'm gonna do it 3 ways for you. One, in order to find the magnitude of QR, you need to know the vector QR. You could, based on the fact that you're on the grid, you're looking at the line and the line is well ruled up. You could employ counting, but be careful with your counting. This is 1 unit. So not because you're used to jumping here, this is not 1. Make sure that you jump for 1 based on what the grid is saying. So the scale is important. Everybody, the scale is important. So 1, 2, 3, 4, 5, 6 to the left. So that's a -6. And then 1, 2 up, +2. So QR is actually -6, 2. Tell me if you are right with that counting from Q to R. 6 places to the left, all right? And then 2 up.
Sir, excuse me, please.
Yes.
Why you didn't count it at the one like you have done before, the one?
Go ahead. What you say? Why? Yeah, because Karen, you have to look on the scale, and this is why you're in class before the exam. You're not just jump because you're jumping. They put 0 here and then put 1 all the way here. Then they put 2 all the way here and 3 all the way there. So you can't create your own based on this. This is already there. So you have to count based on what you get from
Oh, I
them.
see.
You see
I
the
see.
point now?
Yes,
Because
yes.
in the exam, a lot of people
Screen
got
was
12.
down and I couldn't see that. The screen
Ah,
was, I
exactly.
see it. I
So I'm
see it.
just, yeah, man. So you have to be looking out of your eyes because a lot of people put 12, negative 12 and 4, in the exam, not realizing that, hey, look at how they label their thing. It's not like you did it for yourself. You understand? You see what they have, work with it. So you're looking out of your eyes every step of the way. All right. So let's find another way, or we could find QR. So I'm gonna just jump at it. QR. So remember that we have OR, and OR was negative 1, 4. All right. Remember that you have OQ, and OQ was actually 5, 2. I'm suggesting that if you want to find QR, you had a few options. You could say Q to O plus O to R. That's what we have been practicing. So Q to O will go in the opposite direction of OQ. So it's going to be minus 5 minus 2. And then OR is the same, negative 1, positive 4. Look at the answer. Negative 5 plus negative,
That's what I did, sir.
negative 6. Huh?
That's what I did to get it.
And get this say, all right, good. And now remember, we learned 3 ways. So I'm going to do the 3rd way, and then we'll move on. So now you could have done, so you could have done the counting, or you could have done this. All right. Or lastly, you could have said QR is going to equal to OR minus OQ. Remember we said that. OR is actually, where's OR? Oh, negative 1, 4. And you want to minus OQ, negative 5. Hold on. That 5, 2 should say. See it there? So what you're looking at is negative 1 minus 5 is negative 6. And this is actually 2. Let me answer somebody, people, in the class. All right, guys. All right. So now that we have QR, so if they want you to find QR, remember we did say all you're going to do, have your square root, and you're going to be squaring. But remember, with the negative numbers, don't play with it. Put a bracket around it on your calculator. All right, so that's 36 plus 4 and that is the square root of 40 units. There you are. You could give them that, and you're good. So it's not really bad. All right. So sometimes they take it easy, but they don't take it easy all the time. All right. I want to go for another one. All right. Allow me to go for another one. Let me go for number 3. Number 3 might be long, so let me just take it out. Oh, it's not really. Oh, I think, all right, this one is good to talk to you about. This one is from ancient days. There's no space to work. All right, good. You could write this one off while we're working because it's short. So this is one of them that you can write. I'll take myself off the screen for that. All right, I want space. I'm saying you can write this one off. So you see the title for number 10, vector and matrices. They're tied together because vectors is in a matrix format a lot of time. All right. So this is number 10. It was number 11 a few years ago. All right, let's go. This one says the points A, B, and C have position vector. So they tell you, they love to use position vector. OA, so the arrows move from O to A, 6, 2. OB, OC. So you're told all of those info. Express in the form X, Y, the vector. Guys, I want you to do this for me. Go ahead. Do that for me, please, everybody. Do it, do it. I will interject. I will right here. I'll come in at number 2. So I want you to do this for me. These are questions that are coming. So I'll come in at the red marker. I soon tell you what it is. Oh, well. Oh, okay, so you're going to use the right terminology. You have to say it's parallel. Then when you find out that, you tell them, say, that parallel to that. I tell you, two things they want. But you have to say parallel if you're not. All right, let's go for it. So I'm just gonna, all right, let me put BA out here. So with BA here, we have the information already. So I'm just gonna work it one way. So BA would mean you could move from B to O, and then you pick up from O and ended up at A. So BO, you're going in the opposite direction here. So that's -3, -4, plus OA, 6,2. Finally, make sure you're not making any errors with your numbers, right? So this is going to be +3 and a -2, right? So that's BA. From B to A, the vector is +3, -2. Now let's look at BC. They want you to do BC as well. So it's up to you. I'm just going to do this the other way. So it's going to be OC, just doing the two methods for you, minus OB. So OC is 12, -2, minus OB, and OB is 3, 4. So 9 minus 6. All right. So BC is 9 minus 6. So guys, I was expecting you guys to get these, right? So we have that and this. Confirmation from people.
Yes, sir.
Yes, sir.
All right.
Yes, sir.
All right, so we are going then. No, let us know. Look at this. All right. So now it says state one geometrical relationship between BA and BC. Just one. I will say to you here, you need to make a note. Everybody make a note of this that I'm going to state. Whenever you're doing vectors and they ask for geometrical relationship, I'm just telling you exactly what the question will be like all the time. So when they ask about geometrical relationship, one, it's going to be parallel, nothing else. Two, it's going to be the length of the vector. Comparison of the length. Or the size of the vectors. That's all they talk about. And whenever you find the thing that makes them parallel is the same thing for the size. Watch what I mean. Let's talk. So I'm just saying to you, note this down today, that you're doing vectors and they ask about geometrical relationship. Look for parallelism and anything that makes one parallel to the other. One vector is that bigger. I'm going to show you what I mean. Now, observe AB and BC. See them here? Look, is it true that if you multiply 3 times BA, you will get BC? Look at it. So then I'm saying 3 times BA, see it there? 3 is 9 at the top. 3 times -2, -6. So you see for true. The moment you are able to find something that does it, it means that they are parallel. The fact that this was able to move BA and turn it into BC that is telling you that they are parallel. So the geometric relationship is that BC and BA are parallel. And I'm telling you, but you can't just write that they are parallel without showing them how you know. So all you have to do is to show them this piece. Or you could show them this. You don't have to show them the two pieces, you know, one of them will work. It's just because I'm teaching you, I'm working it out. No, you could work it another way, you know. Hold on. Because everybody view things differently. You could have said 1/3 of BC is equal to BA. You could have said that as well. And I'm saying this is or. So I don't want you to think like this is the only way. No. Somebody see it from that angle, another person see it from the other angle. So we're talking about saying 1/3 BC. Look. Remember you did matrices, you know. So 1/3, meaning 1/3 times 9. Let me push this up so you could see what we're talking at the top. Underneath 1/3 times -6. Look what you get. 3, -2. So you see you manipulated BC and it turned into BA. This is telling you that they are parallel. Same conclusion. They are parallel. BA and BC are parallel vectors. Right? Now, when you find out that they are parallel, it's going to be a scalar factor that change one to the next. And remember, if you are 2 times somebody's age, then the other person can say that they're half of your age as well. So you can see the inverse of the idea. If one vector is multiplied by 3 to give you the other one, that means if you take 1/3 of the bigger one, you get the smaller one. So guys, you have 2 things to say. Just pick one. Don't do the 2. So what I'm saying is one relationship is to state that they are parallel, and you would have proven that by showing CXC that you can take one number, multiply by one vector, and show them that you get the next vector. That's all. And when I say a number, it could be a fraction, it could be a whole number. Fine. Negative, fine. The next thing that you need to note. So I'm going to do it from 2 sides because I really want you to get this. Remember, I'm doing this from 2 sides. This was one argument. Somebody would have said that over that side. Argument 2. Argument 1, I would still say they are parallel. And another thing, believe it or not, which one of these is the bigger vector? Would you agree that it is BC, the one that says 9, -6? It's the bigger one in terms of longer. What do you think?
Yes, sir.
Watch this. If you have to multiply the small one by 3, you know what I said about its size? It is, look at this. You could do this to them and win the next argument. Watch. 3 times the size of BA. Watch this, you know. Remember, I'm talking in math language. Equal to the size of BC. This is the next argument. You don't have to do anything. You don't have to do any, matter of fact, the 2 arguments, this could have been 1. This literally, you don't have to say anything. And this is the second argument. The relationship I'm talking. If you write that on your exam, and the next, if you write what I mean by that, this argument and this argument, without writing anything else, you're good. Because these are language. It's a communication going on right now, right? You're sending a message when you write it like that. So the same thing that shows you parallelism, it means that one vector is that longer than the other vector, but you have to use the symbol for length this time. So now that's your second argument. Over the other side, this would have been your first argument, and your second argument would be this: 1/3 the size of BC equal to the size of BA. Guys, every time you get a vector question, it's about parallelism. And parallelism can turn into length of sides as well for a second argument. So, second argument here. If you were using 1/3, you would have written it up like that. See the point now? Always. And I'm saying always. So I hope, I'm going to see if I could find, more. Let's see if we can find more questions and then we see what we have. There's another question there that we have to do. So guys, parallelism is to take a number, multiply by one vector and show them that you can get the next vector. All right, just manipulate it. You will see, when you look, you're going to see it, man. You are going to see it. Just look. All right, you will see it. All right. All right, let us look at the last piece, please. That. When they said draw a sketch, this one. And remember to watch over the recording, guys, don't waste it. It says, all right, this says draw a sketch to show the relative position. See them say relative position of A, B, and C. This is like they want to know if you know how to plot points. So relative position, for example, let me tell you what they want. All right. Can I just put this right here? I want you to see. All right, watch me. All right, watch me right here. You could do it as well. Watch. All right, say if you have your X and your Y axis like that, right? Now, can I go somewhere where I'm seeing the coordinates, please? All right. Allow me to take this aside for you. So you would agree that the coordinate of A is 6, 2. The coordinate of B is 3, 4, because you want to be able to be flexible, back and forth, moving from vector back to coordinate to vector. So in terms of the points, because they asked about the points, position of those, where are those points? So I want to do it in a clear. So you want to have something like this in the exam. X, Y. So you're going to, so 6, 2. So if 6, you don't have to count 6 in it, but 6, 2, you're making up, you said this is 6, 2, you call this A. All right. So in other words, you're saying about 6 on the x-axis and 2, fine. 3, 4. 3, 4 is going to be somewhere here and then 4 gone all the way up here. So I want you to understand it up. You're not going to put on numbers on your axis, but based on the numbers that are here, you will have an idea of the place that it should be. Think again. 6, 2 about there. But 3, 4 is going to be somewhere here and 4 all the way up here. Yeah. And then now when they said 12, -2, remember this is 6 here. So 12 all the way out here. So you're talking about 12 all the way out here, so -2 underneath the axis. So I'm like, I could put it anywhere here like that, and that is C. So you want to understand that 12 is further down the line and -2 is under the x-axis here, and that is C. Idea. So they want to know that you are able to do that. Tell me if you see the point we're making. Relative position of them. That's what they meant. Take a look at those quickly. But it's A, B, and C.
My God.
All right. Let's pull another one, guys, please. Let's pull another one. So that's number, I don't know, number 3. Just pulling them. They might, I think this one looks like one of those one that will give you some stress. All right, let's look at it. See what I mean? Look at that. See, they're giving you, this is what I'm saying. Sometimes they're going to do that. What they're going to do? Sometimes they're going to give you things to count and things, but I mean, if you're going for an exam, you want to prepare for whatever may come. So look at what they're saying here. They did say here that M is a point on QS such that QM to MS is 1 to 2. See that? They're telling you 1 to 2. 1 part, 2 part. All right, no problem. So we're seeing that. All right, so that information is given. Just like what we're saying, they'll do this to you. What are you going to do? Relax and use the information. So QS was split into, is actually 3 pieces. You understand? 1 part get, this person get 1 part, this one get 2 parts. So it's thirds. So you are going to get 1/3 of something and you're going to get 2/3 of it. Basically, that's the idea that we're going to use when the time comes. But let us see what they're doing. So you could see the algebra coming out on this diagram where they're using U and V in the question. All right, so we're not getting the coordinate. We're getting the algebra aspect of which we are saying that. Look out for algebra as well, right? All right, going forward, it says write in terms of U and V expressions for. No problem, write expressions for QS. You wanna look where Q is, where S is. I'm gonna use a color thing to help us to see what they want. So they want QS, which is this. And we could put the arrow on it. So they want it to move from Q to S. Fine, fine. Want me to move from Q to S. So if I'm gonna move from Q to S, this looks like a parallelogram too, but we don't know yet, but it looks like a parallelogram, eh? If you're gonna move from Q to S, isn't it true that you could say that QS would mean that you wanna move from Q to P, and then you move from P to S. Just tell me if you agree with that motion, that plan of action. Tell me if you agree with it.
Yes, sir.
All right. So now let us know. So that is your walk that you're going to take. And you could have taken another walk, okay? You could have go QR, RS, you see it? Everybody see what we're talking? QR and RS up top. You could have go up top too, but I'm not ready to go there yet. So QS. So what you want to look on now is your first move. QP. Look at the arrow. The arrow is not going the way in which I want to go. So it's not going to be U. I'm going to have to put a minus U because I am coming the other direction. All right, guys? Minus U. And PS is normal, so this is V. That's it, you know? Minus U plus V. And we're good. Anybody? Any question? Good? Anybody not saying anything?
Yes, sir. Yes.
Good, sir.
Okay. Oh, because it's easy. All right. It's 1 mark. You say it's easy. See another 1 mark here. It says QM. So now you're going to have to think about what they said about M. So you're moving from QM. QM. So you want to stop here from Q to M. But they did tell you that there is a certain relationship going on. Look, they did tell you QM to MS is in a ratio of 1 to 2. And when we say 1 to 2, it means that this is 1/3 of it and this is 2/3 of the thing. So out of the 3, you get 1, out of the 3, you get 2. So that's it. No, the fact that you have the entire QS, remember, I know you have QS. Look, so the one QM, let me tell you what QM is. QM is 1 out of 3 of QS. That's, let me go back for you to see it. This is what we're talking about when we were looking at the ratio things. Look, QM is 1/3 of the entire QS. All right. And we know what QS is. QS is negative U plus V. Oh, so that means it is equal to 1/3 of negative U plus V. Yep. It's 1/3 of it. That's it. Or what if you are a person who want to slide the 1/3 inside? You could have done this. You could, but you don't have to. But I'm just saying, you could have said negative 1/3 U plus 1/3 V. Is the same thing that. It's just that you're distributing the 1/3 inside. And you know another thing that you could have done with this, I'm just showing you, you know, all the ways that you could have represented this. You could have done this. 1/3 means that negative U plus V was divided by 3. See that? Those are 3 ways you could have written that one answer. And any one of them you feel comfortable doing works. They are all the same. So I could put or. That means we had options. We could have written it like this, like that, or like the other one. So the instruction you got about QM would have led you to understand this. And then from that, you could start do some things. All right. And these are the harder types, you know. What I mean, when they start giving you this, these are like the ultimate questions. These. Any questions surrounding your algebra there? Anybody? All right. Done? See? B1? Really? Okay. It's finished. Hold on. I'm looking to see if there was something else to do. Okay, it's done. All right, so they're asking about MR. We're gonna do MR for them. All right, so I'm gonna do MR up here. So let me look to just show you. They are saying show, hold on. Show them. So this is the last part. It says, show that MR is 1/3 positive U plus 2V. They are saying to show that. So I'm going to write it up top so we could work up there so that you could look at it. So somebody remind me of this 1/3 U plus 2V. MR. So this is what we are going to show. All right, let me put it up here. You want to show. They said show that MR is equal to 1/3 positive U plus 2V. Show that. Sometimes what you can do is write this to suit yourself, like understand that the 1/3 could go inside. So you're talking about 1/3 U, and then the 2 is gonna be on top of the 3 in this one, and you get 2V like that. So what you're looking out for, if you're working out the math and you end up getting this, you know that you're correct. And if you're getting this, you know that you're still correct. I'm saying learn to see the things in various forms so that you can accept some reality when you're working, because a lot of people would work and get the answer and don't know. So I want you to understand that you can distribute and take a look. All right. Now, let's go about what we want to find. Let me clean up this a little bit. All right, I'm gonna put an arrow here to show you what they want, and then we could put back some stuff. we want to find MR. MR is our intention. And let me put this in another color, if I can get it. All right. I think the board freeze. Just give me a minute. All right. Let me put by the line for a minute. Sorry. Line disappeared on me. All right, there it is. And I'm going to put the arrow for the direction. There it is. All right, let's think. Show that MR is that thing up there. Now, let's talk. If we're going from M to R, there are a number of roads that we can take. So you know that when you look at this, this is going to be the same thing as B. And this U is the same thing as U here, in the same direction. You can see it's a parallelogram, right? So you can go two ways. But you know why I'm going to go this way? I have QM already. So you see, because I have QM, I'm going to go this way. I know what QM is, so I'm going to go this way from M to Q, and then move from Q to R, and I would get MR. Tell me if you don't agree. So we're just going to walk from M to Q, and then walk from Q to R. So MR, so when I ask you to show, you know, all you have to do is to find it. MR is to move from M to Q, triangular walk, plus move from Q to R. But you know, when you see this shape, you know that this is a parallelogram. And based on the fact that it's a parallelogram, you are now able to know that V here is the same V there. All right? It's the same V. And U is the same U. Right? You know that. So here is the thing now. Let's just furnish the diagram. We just found QM. Anybody want to tell me what is QM? See it there? We're going in the opposite direction now. Somebody look at this. Jody, look at this for me. This is QM. Negative 1/3 U, 1/3 V. So watch this. If I'm going, so let me write QM for us. This is QM. And it is negative 1/3 U plus 1/3 V. I am going in the opposite direction. I'm going MQ. That means I'm going to have to change the sign. So the negative 1/3 becomes positive 1/3 U. And you could see that.
Negative 1/3 V.
Exactly. And this is what we're talking about, putting everything together. Not a hard thing to do. Relax. So that is just M to Q. Now you need to find QR, but QR is V, straight up. Q to R is V. So you're gonna add V. And V mean 1V now. You done, you know, everybody say it finish, I want to say it finish. Look, you agree that there is nothing to add to the U in terms of variable. All right, you see, when you're doing your vectors and they give you variables, in your algebra world, and same principle, you know, variable you work with. Is there any U to work with? No. So I'm going to have to write back my positive 1/3 U. Everybody say we kind of match up already. Positive 1/3 U come out. All right. Then no, if I have, tell me, if you have negative 1/3 V and you add 1 V to it, anybody know what you get? If you take, look, V with a negative 1/3 V, isn't that positive 2/3 V? V mean 1 V, you know? So if you have 1 dege V and you subtract 1/3 out of your V, you're left with positive 2/3 V. Tell me if you don't agree on that. Tell me if you agree. This is a negative 1/3 V. This is a positive 1v. So when you merge them together, it's like you're subtracting 1/3 from 1. So you're left with positive 2/3. And it's done. This is a full vector question. See there? This is this. So when they said show, you just need to work out how you learn how to do this and make sure that you show them what they wanted to see. That you're done. All right. Any questions surrounding that? So when you're working out these though, as you could see, your algebra has to be, you know, upscale, but they're doing some simple algebra in your vector. It's like they're doing algebra fraction most times. You're gonna get some fraction in algebra. Just take your time on. All right. And this is an old one. You see 15 marks down there? It's not recent. And when I said it's not recent, I mean it's a lot to do because it's a 15-mark question. This was the days when you'll get in section 2. See, this is question 13. In section 2, they had 6 questions around there, and you pick 2 from it. So there will be a full thing on vector and matrices. You're not doing that anymore. Why am I giving you the question? Because all the pieces are important, but you're not gonna get all of this to do on one question ever. You'll get parts of it, just like what you're seeing just now. All right. All right, we won't be able to finish this though, any at all. But I put it out there. All right, so let's start. It says, okay, you see in O to K up here, big letter, and OM are position vectors such that OM is K and OM. So they're telling you the labels. All right, fine. And they tell it's a position vector O, right? All right, so they told you some stuff. Then they said, sketch the diagram above. So that time in the exam, you used to draw. You're not drawing anymore. I could tell you that, all right? So I'm saying, let us say this is the sketch we're looking at. Show the approximate position of the points R and S such that, okay, so they're going to give instruction and you're going to show them where you think it is. So look at this. You want to show where is R and S such that R is the midpoint of OK. All right, no problem. So I look at OK and I say this look like the middle and I'm going to call it R. It's very simple, you know? Don't overthink it. R is the midpoint of O. That's it. And then S is on OM such that, remember, I know we just, you know that this is what we just did. So they're saying S is on OM such that 1/3, such that OS is 1/3 of OM. Okay. So I'm thinking if I put this in thirds, probably third is right here. I'm thinking maybe roughly, yeah. So this is S. Yeah, right there. Because basically they are saying, look, put S on it so that from O to S is 1/3 of OM. And we're seeing like it's in thirds. See here, that's the other 2 pieces. All right. All right, good. So that's all. So even though it looks like it's something dangerous, it's just that we were talking about. See here, you put it on. All right. And this is what you would have gotten 2 marks for. Read and do what they say. Next one now. Look what they asked for now. Write down in terms of K and M vectors. MK, M to K, MK. Look, they want you to move from M to K. MK. Do as we say. Come. M to K. You're moving from M to O and then move from O to K. M to O, this is the arrow going the other way. So it's going to be negative M because I'm going the opposite direction to that. And then I'm going from O to K, which is the same as little k. That's the answer. And this is what we're doing. And we're saying, look out for those stuff, right? Look out, look at your motion and things like that. All right. All right. This is what I'm going to do. I'm going to allow you to try the question, but definitely, I will leave this here. I will definitely have to come back and do, as I said, time, you could see that time is up on us. We have circle theorem to do. I will finish this question for you. When we come back to the next class, you could try it. And then I want to do circle theorem in that same class. So I'll spend 30 minutes more on vector, and then we start the circle theorem. It's gonna take a 2 full class. And then I'm going to start going through past papers because the exam is like right around the corner. So by the time we're done circle theorem, I could tell you we'll probably get 2 classes to revise. And what I mean revise, I mean, we'll probably just pick, we'll probably pick a paper like 2018, 2019, and send it to everybody. And we'll come to class and go through the paper. All right. I want us to go through the paper. Yeah. Yes, Leon, it's May 17th. So we don't have a lot of time. We have 2 weeks. I think we have about 6 classes left before the exam. So I'm actually planning out what I have to do. All right. So I'm saying to you guys, see if you could finish these. The others might give you a little challenge, like you probably don't know what they mean using a vector method to prove. I will show you what they mean here. All right, so you can leave the C part for me, for you to learn. Matter of fact, I'm just going to highlight something that you already can think of. It's just that you need a little guidance to say, okay, this is what I need to do. And it could look, not a biggie, not a biggie. You're able to, I think you can push this off. All right. So, I mean, so we're going to talk and we'll sort this out coming in the next class. All right. So you remember now, you can see the question on the recording. Go on the recording, you get the full question. It's there. So I'm going to stop the recording now. You would have seen the question